So we have a tree that needs to come down, and it's important that we, again, speak in terms of a plan. And before you fell a tree, we want to walk down through the plan to get to step 5 and say, yes, I'm going to proceed because I'm competent and confident in doing so, or no, I'm not going to proceed and I need help, whatever that might be. So I want you to know that this is not a magic wand. It's merely a process to get you through to step 5 to say, yes, I'm going to proceed, or no, I'm not. If you look at my tree here, what would be the first thing that you do before you want to fell a tree? I mean, you come up to a tree here, the knees comes down. What's the first thing that you would do? Yeah, I mean, site analysis is good, or determine your hazards and obstacles, right? Hazard is something that can cause a problem to you. An obstacle is something that you can cause a problem to. In many terms and times, power lines, for example, are both a hazard and an obstacle. You want to determine hazards and obstacles in keeping to a plan that approaches this from a safe side or safe distances, as well as you need to have a place for the tree to go. If you're working out in the woods and you have nothing but trees, the only obstacle really you might have are other trees. You need to have a place where the tree will go. So hazards and obstacles assessment or site analysis will help assess where you want the tree to go. So if you look at my drawing here, you've got power lines to the left. I can't go that way. I've got a fence behind me. I can't go behind me. You want to take information about the condition of the tree. Does the tree have flare at the base, meaning a good healthy environment it's on? If it looks like a telephone pole into the ground, maybe there's been some excavation or something done that could be creating some factors to the health of the tree, if you will. Do you have cat eyes, holes, mushrooms, molds growing off the trunk? Do you have dead branches? Widowmakers, as they would call. These are the things that would come straight down as the tree moves. We want to make sure that you were aware and have taken information on that. How about wind? Can wind help you or hurt you? I mean, yeah, it can either or. Now, I don't disagree with you that when I come up to a tree, I want the tree to go in the direction of the lean. It looks like that tree is leaning a little bit to the right if I can do so, and in this case, the wind would actually be helping me push it that direction. However, I have a house, it looks like, and I don't know, I'd still like to go that way as long as I knew the house, or the obstacle, if you were, is far enough away. So you need to be able to take a good measure of height reading, and you can do it very easily by just picking a stick up off the ground. If you pick a stick up off the ground to read height, let's just say that I want to measure the height of this wall inside here with glasses on, of course, from your cheek out. You're going to make 2 sections of line. So from here to the end of my stick equals from here to my cheek or to my eye, if you will. As I keep a 90-degree angle here, in other words, you don't want to change this to 120, you don't want to make it 45, keep it at 90, lowering your shoulders down to the base of the tree, looking at it here. When that is framed at the base, and when you look at the top, you can walk forward or backwards so that you frame the top of the tree at the top of the stick. That line sight going up forms the third side of a right triangle, and from that place where you're standing, that's where that tree will come down. Now remember, you're measuring to the bottom of the tree. If you cut your notch 3 feet up, then you're going to be 3 feet shorter, but it's always better to be shorter than longer in that calculation. So if you were to walk back here in this situation, and my back is on the house, and I've got this framed to the base of the tree, and that I still see tree above my stick, it's not framed at both, then I know that that tree is going to get into the house, and in this case, I cannot fell that tree to the house as much as I'd like to. So based on everything here as well, bees and deadwood, you have wildlife considerations in some states. You want to be careful about those types of things. Certainly deadwood and bees can be a hazard because they're attracted to heat, vibration, noise, and the color. And that's everything that you've got going on when you're using a chainsaw, if you will. So in this situation, again, I can't go right, I can't go left, I can't go behind me. I'm going to go literally out here in front into this open field. And I'm going to say that that open field is directly out here in front of me down this aisleway here. You need to have a place where you want the tree to go first. A lot of people would say, look at the leans of the tree first. You want to assess the hazards and or obstacles first, because the tree can go a lot of different ways. It doesn't have to be just in the direction of the lean. You can do a lot of things with it. It's got to go into a place where it's not going to hang up or create problems to other obstacles. So that's where I want the tree to go. Step 2 of the process is leans, L-E-A-N-S, plural. Because when you look at this tree, you certainly, from your view, can get an idea of the side lean of the tree. How to determine that calculation is from the spot that you've determined where you want the tree to fall, generally about 30 feet out, because you get a good trajectory or view of the crown. Is it going to hang up? Is it got a free flow of motion through the tops of other trees? From that point, literally look at the tree straight on and take your left hand to the furthest branch to the left, your right hand to the furthest branch to the right, and drop a plumb line down. Now, after you frame the crown, a plumb line is if I would shimmy up that tree and hang a little fishing line with a weighted line, that line falls straight down to the bottom, irregardless of the lean of the tree. It doesn't discriminate. So how it would look would be to the left and to the right, and then a plumb line. I just take one hand, move it over, and drop it straight down. So if you're framing from here to here, about middle is here. If you drop a line straight down to this point here, you would measure from there to the base of the tree, and I'm going to say that that is 2 feet of side lean. So you can tell that the tree is leaning to the right, and you know it's got 2 feet of side lean. That being said, is if I aim my notch on the saw, the felling mark on the saw, if I aim to try and aim it right at that X, I'm going to miss that X by 2 feet to one side or the other. Because what we've got so far is, even if the tree's leaning forward, it's leaning 2 feet to the left, and it creates a pivot. That line, that tree is going to fall 2 feet away from where I want it to go. So how we fix that is by aiming the saw not directly at the line, but aiming it 2 feet opposite of the lean. Then the tree is pulled that way and brings it right down to where we want it to go. So that's how you determine the side lean, but it's leans plural. So I ask you, is this tree leaning towards you or is it leaning away from you? And you can't tell because they're two-dimensional, if you will. You can look outside here and you can do side lean on anything, but I can't tell the front or back lean, nor can you. So you just simply move from that spot to 90 degrees adjacent either side and do the same type of calculation. One hand to the back branch, one hand to the forward branch. You got that frame now. Take one hand to imaginary point equicenter, which is going to drop a plumb line straight down. I'm going to say that that line comes down 4 feet behind the tree. So what does that tell me about my situation? It's got 4 feet of back lean. So it's leaning back quite a bit. So I got a situation now where the tree is back 4 feet, to the left 2 feet, to get it to go to that spot in the center. Okay? Leans, plural. Step 3 is the planned retreat, or what we would call escape route. If you look at this tree leaning that way, as it is moving, and it's leaning to the left, as it's moving, there's a chance, if it does break free from the base, there is a chance that this tree is going to fall to the left of where I want it. It's going to go to the side lean side of the tree. So that becomes the bad side of the tree. We want to, when we can, escape to the good side at a 45-degree angle to 15 feet, if you will, distance. It's not about how far you get. You don't need to, and rule 102 is don't turn your back on it. It's about getting to 15 feet and then making sure that the notch and the hinge are working and the tree is going in the right direction. You're not behind the tree, you're away from the lean, and you're on the good side of the tree. Okay? Your escape route or your planned retreat. Step 4 would be the hinge. Before we even get into thinking about this tree, we want to determine the hinge. Again, the hinge calculation is 10% of the DBH. DBH, diameter breast height, is at 4.5 feet above the ground. So I'm going to just measure that tree at 4.5 feet above the ground. If it is 20 inches diameter, 10% of 20 is 2. So we would want the hinge plan of our tree. Here's again looking through the top of it. We would want it to be 80% across the face, and we would want the hinge to be 10% of that diameter uniform all the way across. So you got to know, on a 20-inch tree, that hinge would be 2 inches wide, a little bit wider. On a 30-inch tree, 3 inches. On a 10-inch tree, 1 inch. Because too thick creates too much wood, and the leverage at the top as the tree is moving can create a snap and bind because the hinge is too thick to allow movement, but you don't want it too thin because you have to have it holding all the way down as well. It has to be right at that 10% DBH, if you will. So that's our hinge calculation. And then our back cut plan is step 5. And the back cut plan is, once you put the notch in the tree, you need to say, am I going to cut this tree from the back to the front? Or what am I going to do and what do I need? Now in this situation, we've got side lean. We know how to deal with the side lean by aiming one way or the other to offset that amount of lean. And the front to back lean, that becomes another issue entirely. I mean, if you have a tree leaning back 4 feet and it's going that way, at a minimum, you have to pull this thing 4 foot an inch before it goes on its own. So if you have a rope in a tree, a good rule to remember is to have that rope at twice the length of the tree. You know how to measure the height of the tree. You can double that. You don't want a rope pulling that's too short for obvious reasons. And you also want to manage where that rope is set. I mean, too tall, you can get it into flimsy branches or crotches and pull the crotch out or break the crotch out of it, or it's not enough wood fiber to pull it. And too low, you start losing your mechanical advantage. So you've got mechanical advantage up high, you lose it coming down low, so it becomes a game of you need to be not to the tippy top, but somewhere where you have a stout enough branch. Don't come down too low because you lose mechanical advantage, and that way you can get the tree to come over the 4 foot in this case for it to ride on the way down. Now that's the next point. If you've got a rope in the tree, you can pull it up to 4 foot and an inch. But if I aim my notch directly at the point where I want the tree to go, and this tree is leaning to the left, I can pull it up over top dead center, but that tree is going to go to the left now when I let it go, because you can pull it up, but as soon as it goes, it's on its own. You can't pull it fast enough and keep tension on it, enough pre-tensioned all the way down. It's going to go, you're going to lose it to some drift to the side lean, if you will. So what you have to do with the rope in this case even is, you have a rope tied in, you'd still, when you put the notch in the tree, you still angle that notch 2 feet to the right, because after you pull the tree or use mechanical advantage such as come along or winches or certain types of apparatus, it's on its own and it's going to go in the direction of the side lean. You're not going to have control all the way down because you can't pull it down that fast. So that's rope. A lot of people would say, how do you deal with the back lean? Well, you use machinery. Get the bucket truck. Well, you know, most of them get up about 25 feet. Say you've got a tree that's 80 foot tall, we'll say here, and we could measure that, right? I mean, if you got a tree that's 80 foot tall and with leaning 4 foot back and you can only get the bucket up 25 feet, I mean, you don't have much mechanical advantage, and that's where your rollover protection comes in, because a lot of times it just pushes that tree back over and on top of you, if you will. I like using wedges. Wedges are in the form of a polymer wedge, if you will. These are for felling trees. They create lift is all they do. They're not for splitting wood. They're polymer, if you will. If the chainsaw comes in contact with the wedge, it has no bearing on the sharpness of the chain. It's going to keep cutting sharp and everything's good to go, if you will. So I just use wedges. Now, my question is, if you've got a tree that's leaning back 4 feet and 2 feet to the right, we know we got to move the top 4 foot and an inch before it goes over on its own. You have to, as part of your plan, you have to calculate the segments of the tree, or you have to understand, you have to know how many of these wedges are you going to use to get that tree to go up and over. So let me just ask you, say you got a tree 80 foot tall, let's just use that. So you're going to put a notch in here, right this, and you're going to aim 2 feet opposite of where you want it to go to compensate for that side lean. Say the tree is 12 inches DBH at breast height, 4.5 feet. So right off the bat, you're saying that your hinge needs to be 10% of 12 or just slightly over an inch. 1.2 would be the exact, but it doesn't have to be that precise. A little more than an inch, or about an inch, if you will. Now, there's all kinds of considerations that come into play regarding wood fiber, pine versus hardwood, all that kind of thing with species. But for the general rule of thumb, 10% of the DBH is going to get us to where we need to be. Thin enough to hold and move, but not too thick to where it's going to snap and break. So if the tree is 80 foot tall and it's 12 inches wide, the segment of the tree, a segment is nothing more than a square. The segment is based on the diameter at breast height, DBH. So if at DBH I have a 12-inch diameter tree, I have essentially a 12-inch imaginary segment that I'm dealing with in the tree. If you have a square, and this is 5 inches by 5 or 4.5 by 4.5, whatever it is, whether it's 4 feet by 4 feet, if it's square, if I push up on the bottom of this square, it moves the exact amount at the top of the square, wouldn't you agree? If I push up on this an inch, it moves 1 inch at the top of this wedge. So figuring the segment of the tree, I say it's 12 inches diameter. I got a 12-inch segment in that tree. My next question is, how many of these go to the top of an 80-foot tall tree? Yeah, 80 of them. 80 segments go to the top of that tree. So I want you to look at this. If I move this an inch at the bottom, and I'm using an inch because the wedge has a 1-inch shoulder to it here. If I get the wedge in behind the tree and move it an inch, I've moved that square 1 inch, correct? 1 inch. If I've got 2 of these on top of each other, and I moved the bottom one 1 inch, I moved it 1 inch, and I moved it 2 inches at the top of the second square. If I've got 3 wedges on top of each other, or 3 squares, excuse me, segments, and I move it an inch at the bottom, it's 1 inch, 2 inch, 3 inch. So it compounds every square, it compounds an inch. So in other words, I would get 1 inch, 2 inch, 3 inch, 4 inch, 78, 79, 80 inches of movement at the top of that tree with just one of these little wedges. So my tree is leaning back 4 feet. That would be 48 inches. 80 is more than enough to get me to go over top dead center. Now let me just take that a little bit further here. This will help you. If you have a tree that is 24 inches wide, okay, now you have a fatter tree. Say it's 80 foot tall, 24 inches wide, 2 feet is the segment. Now I only have 40 of these segments going to the top of the tree. You with me? So I'm only getting 40 inches of movement at the top. If the tree is leaning back 4 feet, I'm 8 inches shy. So what we would have to do is we would have to double or stack the wedges. And remember, you never want to stack wedges this way because each wedge will work on itself. When you drive it, it tends to wedge one out, and the tree sits down, it could come over backwards. So when you use wedges to stack, you can put them at a 90-degree angle and put them into the back of your tree and run them this type of way, and they will lock in and they won't shift or move on you. Now you're getting 40 and 40 or 80 inches, more than enough to compensate for 4 feet of lean on an 80-foot tree that's 2 foot wide.